A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement, Construction and Technology, funded by Ministry of Education, Government of India. Our this lecture will be a continuation to our lecture 25, where we were discussing the pavement distress type under the module 11. So, at the very beginning I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, in the previous lecture we discussed about two major categories of the defects which are usually observed and in the bituminous or flexible pavements. They were under the category of surface defects and second was under the category of cracks. Today we will discuss the distresses which comes under the category of deformation, where we will discuss about rutting, corrugation, shoving and shallow depressions, settlements and upheavals are there. And then again we will discuss about the disintegration, where this some loss of material is there. In terms of stripping, we will discuss about stripping, raveling, pothole formation and edge breaking. And as we mentioned previously also, it is very important to understand which type of distress has happened on the pavement surface and to understand what are the possible chances where these can occur, where those distresses are happening, and in certain measures are there, classification systems are already there as per IRC 82, which says that these distresses can be classified into different severity levels also. Now, let us first talk about the deformation. So, if there is happening any change in the original shape of the pavement surface, then we can call it as a deformation. You can see here in this particular one, earlier this surface was constructed flat. Now, in due course of time there has been a depression which has been created. So, I can call it as a deformation. There is some change in shape. Here also you can say this material has moved, has shifted, has moved to, or there is some shifting of the material is there, and here some big shifts of the material is there. So, slippage of the material is there. So, these kind of distresses comes under the category of deformation, where any change in the original shape has happened and which may be limited to one or more bituminous layer, and this may, if this is happening, it may not be limited to the top bituminous layer, it may be has undergone this kind of deformation, has undergone to the underlying layers also. So, it may be limited not only to one layer or one or two bituminous layer and may extend through the entire pavement structure going up to the your pavement subgrade also. So, these defects can appear in various forms. This is a typical slippage distress is there, then you have this rutting distress is there, then this shoving distress is shown here. We will see corrugations also, shallow depressions and settlements also. So, the main categories which comes under the category of deformation of the pavement structures are the slippage cracks, rutting distress, corrugation distress, shoving distress, shallow depressions, settlements and upheavals. Now, let us first look into the slippage cracks. So, this refers to the relative movement. So, your top course or the top bituminous has moved relative to the underlying course. So, this is what, if this is observed, you can see there is a relative movement, the top course has shifted, has moved compared to the lower surface which is intact. Here also you can see the top course has moved, this has failed. So, it has teared off, and then this particular one again here you can see this kind of thing, and when this has teared off, you can observe these cracks which are happening, and they form a typical shape. You can see this is a half moon type shape is there. This is or I can say a crescent shape or a U shaped cracks are there. So, slippage crack refers to the relative movement between the wearing course and the underlying layer of a bituminous pavement. It is typically identified by crescent or U shaped cracks are there. This is a typical shape which is there in case of slippage cracks, with the open end of the U usually pointing in the direction of the applied forces. So, this is a common feature. If now how it happens, if you will find if the brakes are applied, you will always point this U pointing in the direction of the travel. So, if brakes are applied, so this kind of shift which will happen in this case will be having these U pointing in the directions of your travel. And if there is some acceleration is there, in that particular case the open end points towards the rear of your or the opposite of your travel direction. So, this is usually when one layer slips with respect to the other layer, this kind of shape. So, we can very well experience where this can occur. This usually occurs along the wheel paths or where some slow moving traffic is there, specifically where regular stopping and acceleration is happening. So, it may be at bus stops also, at intersections also. So, and where slow moving traffic is there. So, when it stops at the intersections, when it accelerates at the intersections, these are some of the locations where it can happen. So, it is mentioned, and this specifically happens with the heavy vehicles. So, it may be say trucks or buses. So, at bus stops, at intersections, we can observe this kind of slippage cracks. Now, low severity cracking, again high severity cracking, two levels are mentioned for it. Slippage cracks occurring at isolated spots within a lane. So, at some isolated locations, if it has happened, we will call it as low severity cracking. And if it happens continuously along the wheel path, so very frequently you will see along the wheel path it has happening, so that the top layer is getting slipped from the bottom layer, we will call it as a high severity of slippage cracking. Now, rutting, this comes under the category of deformation. So, it is a formation of a longitudinal depression, or we many a times call it as ruts. So, it is the formation of these longitudinal depression. You can see this is a longitudinal depression which has been created. So, it is the formation of longitudinal depressions or ruts in the pavement, mainly along the wheel paths. So, along the wheel paths and along the lanes which carry heavy traffic or the slow moving traffic. Ruts are typically uniform along the wheel paths. So, their depth usually is uniform along the entire length. There can be certain sections where some localized failures may be there in terms of rutting also. It can occur in different pavement layers, and this may not be restricted, as in the case of surface draft effects, to the top layers, top bituminous layers. It may be extending from the underlying layers, which may be your even subgrade of your pavement course. So, it can occur in different pavement layers and is mainly classified based on the cause and the specific layers which are added. So, I can call it as subgrade rutting, or I can call it as the rutting of the granular courses or the rutting of your bituminous bound courses. So, the two ways in which it is characterized are the permanent deformation in terms of the upward uplift. This is the uplift which is happening, and the downward movement of the original one, how much the downward movement is going. On the basis of it, we can work it out whether how this kind of deformation is happening in the different pavement courses. Shallow ruts usually do not pose a safety risk. Now, what the problem is, if it disturbs these ruts or the depression disturbs your cross drainage and it leads to ponding of water along these ruts, then it raises a safety concern. So, shallow ruts usually do not pose a safety risk till the water is able to move out from the surface, but when they are deep enough to pond water, then the risk of hydroplaning increases. So, the chances of a vehicle losing its skid resistance over this one. So, when a film of water comes between your tire and the pavement surface, then this hydroplaning happens and the chances of skidding increases. Endangering motorists, this will happen, and even in case of cold climates, this water can freeze, and this will again lead to slippery conditions. So, this is quite challenging if water is getting ponded in these ruts. So, locations where these are most possible chances are happening is rutting predominantly occurs along the wheel paths of the pavement, because there you are going to experience the maximum amount of load which is going to come over the pavement surface. And on the basis of the amount of ruts also, the pavement surfaces are also rated also. So, as per IRC 82/2023, it says that even for highways and urban roads, a surface can be rated as excellent to good if the rut depths are usually less than 5 mm, satisfactory to fair 5 to 10, and poor to fail when it is more than 10 mm. So, similarly, it has been given for the major district roads and rural roads also. Now, the other form of deformation which can be observed on some pavement sections is corrugations. So, here you can see there is some wave like structure is there. So, these are corrugations are there, and again the corrugations may be there in your top courses or may be there from your underlying courses also, from granular courses also, it may happen from subgrade also it may happen, and then consecutively getting reflected on the top. So, corrugations refers to the development of regular wave like undulations or ripples on the bituminous, and this is how it gets reflected. Finally, we will be able to see when any distress comes on the pavement surface. So, these ripples are usually shallow around 25 mm and are more distinct from larger depressions. These are smaller depressions only caused by weakness. I will not discuss much of the cases, but yes, mentioned that it can be there in the underlying courses also. The typical spacing of these waves may ranges from 2 to 3 meters. So, this is how corrugations are there. What one concern may be there, because the driving discomfort is there, because this is specifically, and but when it becomes more severe, when these depressions increases, then it raises a safety hazard also, and it can occur near the wheel path or in the entire carriageway. So, along the wheel path it can happen, or it can happen along the entire width of the carriageway also. So, if this kind of any surface defect is observed, we can say okay, corrugation is happening over this particular one, and seeing how much is the depth, what is the spacing of these ones, we can figure it out. Okay, is this a very extensive corrugation is there or not. Now, the other form of distress under the category of deformation is shoving. You can see a mix is pushed to the side. So, there is a bulk quantity of mix which is pushed to your pavement edges. Here also you can see the mix is getting pushed towards one side. Even the pavement markings gets disturbed in the, you can see the pavement markings has become wavy. So, from there you can get an idea, okay, there is some shear failure of the mix which has happened, there is some shoving which has happened. So, shoving is a type of plastic deformation within, specifically mainly within bituminous layers, resulting in bulging of the pavement surface. So, this has bulged at one particular side. So, location shoving typically occurs at points where traffic frequently stops or makes a turn. So, at curves also, at intersections also where it stops. So, high shear stresses are generated specifically when braking actions are there, when it accelerates specifically at rising gradients are there, such as intersections, bus stops, hill roads, sharp curves are there where vehicles accelerate or brake. This kind of the bulging of the mix can be there in the bituminous mixes, and they specifically mainly occur along the edges. The mix get pushed towards the edges. So, it commonly appears near wheel paths in truck lanes or on horizontal curves where commercial vehicles slow down significantly, making these locations frequent sites of this kind of shoving distress. Now, in urban sections also, specifically where bus stops are there, these are the first locations which can experience this kind of corrugations, and as I mentioned, you can very well get them detected by the edge line markings where lines bends. So, you can see the edge line markings when the pavements are there, the edge, you have the edge line markings when the shoving will be there, these edge line markings will get disturbed. So, then you can understand, okay, this edge line has become wavy, the markings for the edges have become wavy, that means there is some mix which is getting buzzed or shoving is happening. Shallow depressions, small amount of depressions, localized depressions may be there. So, these low spots in the pavement can be there. These are, as mentioned, it is usually a localized depression is there, typically around 25 mm or below the surrounding surface. This is a typical depression which is there, and some amount of water, because it is a depression is there, water can get accumulated for this particular one as it disturbs. So, it can be transverse direction and it can be in longitudinal direction also. May occur or may not be accompanied by surface cracking. If this depression is more, many a times you can see some cracks also getting initiated along with these shallow depressions. They may create an uneven, uncomfortable, potential unsafe driving, because the water can pond in these particular shallow depressions. So, shallow depressions are generally restricted to wheel path, heavy traffic lanes are there, where you can see this is a edge marking, this is a shallow depression which is happening. Settlements and upheavals are there. At certain locations you will see some settlement is there and some uphill of the pavement layers is there, bituminous layers, uphealing is happening. So, that is another kind of distress which is there and which will come under the category of deformation. And are permanent deformations larger than shallow depressions. These are because there we consider around a depth of 25 mm. If it is happening more than that, we will call a settlement has happened in this one. They pose significant hazard to traffic opening, often causing reduced vehicle speeds, unsafe driving conditions, and cracks also gets associated with these settlements and upheavals. So, these defects are usually accompanied by extensive cracking along the affected area. So, then they further allow the water to go in the underlying layers. Settlement upheaval may be along the wheel path or isolated locations in a carriageway. Now, the fourth important category of the different type of distresses is this disintegration. So, that means there is some loss of breaking of the pavement material is there. So, which disintegration is the progressive breaking up of the pavement surface into small loose fragments. If my pavement is material or the surface is breaking into small loose fragments, often involving the separation of individual components of the bituminous mix. So, what are the individual components? We have the aggregate and binder with us. In aggregates we have fine aggregates, coarse aggregate, along with the which are bounded together with the binder. So, if some loss of material is happening, then it comes under the category of your disintegration. It typically manifests as raveling. Now, there are few distresses which comes under the category of disintegration, breaking of the material, which are raveling, stripping, or pothole formation is there. Pothole is a very common term which you all might have observed at some or the other moment on any particular surface while driving your vehicles. So, if not addressed early, disintegration can accelerate, ultimately necessitating the complete reconstruction. So, the categories usually distresses which comes under disintegration are stripping, raveling, pothole, patch repair or patch deterioration and edge breaking. Stripping, as the word says, something is getting stripped off. So, what is getting stripped off? The binder is getting stripped off from the aggregate surface. So, stripping is the separation of the bitumen film from the aggregate particles, and this usually happens in the presence of moisture, resulting in, and once this water enters, the binder film is stripped from the aggregate surface, because most of our aggregates are hydrophilic in nature, they have a higher affinity towards water. So, the binder film gets stripped off from the surface, and this leads to a reduction in the cohesiveness of the, or the mix strength is lost in that case. So, it is a loss of bond between the asphalt and aggregate, and a reduction in mixture cohesion will happen. So, this distress usually begins at the bottom of the HMA layer and progresses upwards. Usually whatever water which comes from the underlying layers and gets in contact with your bituminous, because the traffic is moving over the surface, a good amount of pressure, pore water pressure is getting created, and the water which reaches to the bottom of your bituminous layers and remains there, then it makes your binder film get stripped from your aggregate. So, many a times usually on the top from the camber the water goes off, but whatever there coming up from the underlying layers, usually that is one of the main reasons for stripping which is observed. If it happens from the top, then it takes the form of a raveling, which we will discuss in the next slides. So, this stress usually begin at the bottom of the HMA layer. So, if you can open up, if you take out any core and you observe from the bottom, you will see that the binder is getting stripped from the aggregate surface, and you can find these strips, this aggregate surfaces without any coating of the binder. So, location where this usually happens, again specifically lane, it can happen in a lane or the particular lane or along the wheel paths, or it can happen for the entire carriageway. Specifically on multi-lane highways, stripping often happens in the slow moving lanes where the heavy traffic moves over it. Now, as I mentioned, the next is when this is happening from the top, this is the other case when water is there on the top of the surface. and because of this, if there is some loss of binder is there, then there will be loss of aggregates will also be there. So that comes under the distress, which is raveling. Now what is raveling? Is the progressive separation and loss of fine aggregate particles. So when the fine aggregate particles are not able to get holded in the mix, so this kind of separation of the fine aggregates usually initiates. So when is the progressive separation and loss of fine aggregate particles and binder from the bituminous surface. So one of the reason may be if water is standing on the surface. So that's why it was mentioned in the previous that if this loss of material is happening from the top because of water, then it will be referred as raveling. Otherwise, usually stripping goes from the bottom part. But this loss of fines may not be only because of water, it can happen without the presence of water also. So raveling, water may be one playing factor or may not be a playing factor. So it leads to disintegration of the HMA layer from the surface downwards. So it moves from surface to the lower portion of your bituminous layer. So typically fine aggregates are lost first if they are not holded. So if for an example, if inadequate binder is there, it is not able to hold your fine aggregates, then first the fine aggregates are lost, then finally it may proceed with the loss of your coarse aggregates also, and usually begins at the surface or edges, results in a rough, uneven, jagged pavement surface, because as the fines, you can see this particular surface is there, the fines are lost from this particular one, coarse are appearing on this one. Severe raveling can create depressions that pound the water, and if more depressions are there, this can lead to ponding of water also, which can lead to a loss of skid resistance also. Additionally, loose aggregates reduce skid resistance and may be thrown by vehicle tires. This again raises a concerns related to road safety. Then where can be the locations? It can be in a particular lane or through the entire width of it. There again low severity, medium severity and high severity. Low severity is the one when minor losses of fines are there. So usually this is initial stage of binder deterioration is there when we call it, some fines are getting lost of it, and then in that particular case if there is noticeable loss of fines are there, you can see in this particular surface, then this becomes medium severity and the binding wearing out to expose a rough surface here. And if further goes where you have the significant loss of aggregates which is happening, then this comes under the category of high severity raveling. Now the other form is pothole formation. This is an extended form of any distress. So if any kind of distress which becomes very severe, at least it can lead to a formation of a pothole also. Potholes are bowl shaped cavities that penetrate the HMA surface typically and may be extend into the binder or base course. It may go down depending upon the depth of the potholes, but they usually occur on pavements with thin HMA layers. Usually this is most of the cases when you have the thin bituminous layers which are there, and many a times very frequently they occur during the rainfall when water enters and they into the especially the closely spaced alligator cracks are there or any other cracks are there, and then some loss of material starts taking place and in due course of some time some pothole will be formed. So the dislodged pieces of pavements are removed by tire action causing. So if some say alligator cracks are there, they are in high severity condition, then some of the pieces get dislodged by the tires, water gets accommodated inside, it further damages your surface and then finally it leads to a formation of a pothole. Now it can occur along a crack including longitudinal or transverse crack, especially where wheel repeatedly crosses. Now to make a count of it, what the severity is there, usually certain units are used, we call them as pothole unit. So for this particular one, especially I mentioned it is there, it is to define having a surface of area 0.1 meter square and having a depth of around 10 centimeter. So this leads to a volume of around 10 liters. So if a pothole of volume of 10 liters is there, then it is counted as 1 unit of potholes. So on the basis of it, for the maintenance activities, the intensity of the potholes can be classified, okay, how many pothole units are there in this one. Now the patch deterioration, many a times you have seen some patches are made to repair some of the distresses which are localized distresses, but then these patches also get deteriorated with time. So, they also now is kind of distress in the existing pavement surface. So, patching involves repairing damaged or excavated areas in bituminous to restore serviceability and prevent further deterioration. So, this is a patch which has been done over it. Now, timely patching of defects such as potholes is crucial as delays, because this allows that to prevent the infiltration of water and getting the underlying layers damaged. But in due course of time, these patches may also get disintegrated or deteriorated. So, on the basis of it, we can classify the severity of these patches. This is a patch which is quite intact. So, I can have a patch which is low severity, is a patch in a good condition performing satisfactorily with no loss of material. So, it is a low severity. There is some discomfort may be there, but it is a low severity case is there. Then medium severity, when the usually it happens at the edges, you will have some minor issues happening. So, some loss of material may be happening at the edges of this. So, patch exhibits moderate distress of any type, including some cracks may be there, and it happens along the boundaries. And when there is sufficient, it gets deteriorated in significant manner which affects your riding quality, then this is a high severity patch deterioration is there. Now, the last one is under this category is the edge breaking. Many a times you see this is a carriageway edge which is there, this gets damaged. You can see this is the material is getting removed or dislodged from at the pavement edges. So, edge breaking, we call it as a edge breaking, is a defect in bituminous pavement characterized by the irregular fracturing. This is irregular fracturing and disintegration of the pavement edges which are there. Usually it happens very near to the pavement edges, around say 30 centimeter from your pavement edges. If left untreated, now if this is not treated, it gets further worsened with time in this particular one, and these chunks gets removed in due course of time, and it effectively reduce your pavement width. So, this is what is edge breaking is there, and typically confined to the pavement edges and extending 30 centimeter inward to the. So, these are some of the typical distresses which we discussed today under the category of the deformation and under the category of disintegration. Thank you so much.